My boating career started in the 1980-81 when I started racing inflatable boat racing, which was a popular sport in South Africa. And at that time we were in the process of developing faster and better inflatable racing boats. I did this for a few years during my student days, and then progressed on to rigid inflatable racing, and in fact was part of the team, the first team to ever enter racing events in South Africa with a rigid inflatable boat. The boat that we raced at the time was a monohull based on the Phantom hull, which is quite known for a good racing boat in the world. But the event that we've taken part in is called the Trans-Agulhas inflatable boat race, which is a 600-mile race around the southern tip of Africa in some severe rough sea conditions. And the monohull did the job very well, and we managed to do a very good race, but it was dangerous in some instances, and the boat behaved in ways that we couldn't predict, which made it dangerous. And when we finished the race, I decided that I will do it again with a rigid inflatable boat, but definitely with a catamaran. I then started designing my own catamaran, which before I started spending the money in developing plugs and molds, which is an expensive exercise, I decided to call on Professor Hopper, that was known to me at the time as part of our student projects, to ask him his opinion on my design. I then met up with Professor Hopper, and he was very willing to assist with the design part, and suggested to me, why don't we do a hydrofoil supported catamaran. At the time I knew that the hydrofoil technology had been around, but it's been part of the University of Stellenbosch development project, and I started off with very limited funds, and it wasn't possible for me to pay big money for the technology. As it turns out, the company that was holding the patents at the time went bankrupt, and the patents were floating around with the financial department, and I managed to do a deal with the university where they used my project as a feeding project. They called it a technology introduction project. So the design, my design then changed to a combination of Professor Harper's whole design incorporated with a hydrofoil. And that's how the whole marriage between Professor Harper and myself started. We then started developing this new plug and mold in a small facility with assistance of Professor Harper and the assistance of the University of Stellenbosch at the time. And when we completed the development, the very first tests, actual sea trials, were attended by Professor Harper and the University of Stellenbosch. Actually, the very first prototype boat that we put on the water had a phenomenal performance, and again proving the technology on the hydrofoil system. To go a little bit further back to the foil technology, a summary of the technology that's already been introduced by Professor Hopper. In a nutshell, the hydrofoil is creating a high and a low pressure like an aeroplane wing would do. Water and air is essentially the same thing. Water is this much denser than air. So where an aeroplane wing needs to be that size, a boat wing can be that size to do the same job. It's creating high and low pressure, lifting the craft out the water and reducing the resistance. So by lifting the boat out the water, the resistance disappears on the hull. That actually makes the boat more efficient, smaller propulsion, better acceleration, it can carry more load, better sea keeping. When the boat goes airborne and re-enters the water, the hydrofoil acts like a shock absorber, so you don't really get the impacts like you do with a conventional boat. And then also the human fatigue factor, where the people on the boat is not going to take the punishment like they do on conventional boats. So all in all, the advantages associated with the hydrofoil technology is phenomenal. Load carrying capacity is another factor that even with heavy loads, once the foil start moving forward, it immediately starts creating lift forces, and once it gets out the water onto the hydrofoil, the resistance is gone, and you can cut back on the engines and save fuel and energy by doing so.